I'm a lawyer, and so I deal in a lot of crisis as it relates to the food sector. It's something that lawyers end up fussing a lot over in crisis, specifically recalls related to adulteration of foreign bodies, is about insurance and insurance coverage and claims and ultimately, what is the insured risk and to what extent it sort of bleeds out. And I met JP at this conference a few years ago, and I had the opportunity to go visit his facility in Bolton, and it kicked ass. It was so good. And so I'm super pleased to introduce JP Perreault to come and talk to us about X-ray reclaim. Have fun.
Good job, thanks. Hi everybody, good afternoon. Late in the day session. Hopefully it's sufficiently interesting for you at this point in the day. Thanks again. My topic today is going to be really focused on X-ray technology and innovations in X-ray technology. And basically its role inside of food processing, food safety and your production lines, but also where it's leading in terms of new opportunities we have in the marketplace. So first off, I want to start with some basics. Everybody's pretty familiar with inline food safety inspection, classic devices like metal detectors and X-rays. So basically, X-rays will perform density measurement, so inspect for dense foreign material, whereas metal detectors look for magnetic or conductive materials. So essentially, in those two categories, you're looking at basically ferrous, non-ferrous, stainless steel, which is your standard contaminants for metal detection. X-rays, obviously, first generation X-rays give you much more. All those same things, it becomes a little bit confusing when we list ferrous, non-ferrous, and stainless steel, just working off of density purely on this first generation X-ray. But all the other contaminants that we should be worried about, different facilities have different concerns, but certainly glass, stone, bone, plastics, and rubber. So, and what we understand, of course, is that these devices are definitely required part of a food safety program, but increasingly, X-ray is starting to emerge as a new safety standard for companies like Costco and Trader Joe's, issuing new food safety mandates in their audits to include X-ray, even though they haven't quite defined exactly what that means. Programs out there and starting to gain momentum, but ultimately both metal detection and X-ray just form part of a happy family inside the food safety inlines inspection. So in the end, pretty much what we're talking about here today is technology and advancements for the X-ray, and that's really what our expertise is in the Canadian marketplace, and we'll get a little bit focused on our history at the end, but basically diving right in, we see a major opportunity not only in helping food processors and implement the new technology, and we'll talk about what that is, but also what it means to what is a pretty significant issue that we've started to learn about for the last 5 years, which shamefully not really aware of how bad the food waste problem is. So we've been trying to work with the provincial government and companies like, or nonprofits like Second Harvest, just to bring attention to basically the amount of finished goods that through the process of food safety, unfortunately, are ending up in landfills. So with this new technology, and my mission, our company's mission, is to educate and help bring awareness to the fact that we have this technology available and that these third-party inspection services are standing by to assist in a lot of situations where normally you would think about throwing those finished goods out. So ultimately, this technology advancements is a major leap, and it's opening up a new opportunity inside of food recovery. We all know what basics for, functionality for an X-ray. Obviously, foreign material detection. Check weighing is part of the picture in terms of capabilities on X-ray. Shape analysis and also missing components. They're capable, like the more modern solutions, first generation, but still the more comprehensive solutions can perform all those functions for you. So it's more than just foreign material, but ultimately the advancements inside of X-ray are really focused on the foreign material detection, and it's increased so dramatically. On my team, and I have well-seasoned people that have been in X-ray for 20 years, working with this new technology, it's just basically Star Trek for them, and they're like little kids. Unbelievable detection capabilities. So basically, just focusing on here, sorry. So the current, and this is really the problem that we're trying to address or help address. Current rate for food price increases has been dramatic. Basically, we're at 10% in 2023, and the studies are out there. The Food Banks Canada produced a study also demonstrating that there's just dramatic increases in people going to food banks, 15% increase. So there's obviously a food crisis happening, and that's there's many factors obviously associated to this. But we can't ignore the fact that that on a weekly, daily, or monthly basis in any one of your food processing facilities, we're making decisions to send food production into landfill. I know it's a bit of a bummer, right? But basically, there's good news inside of working with innovation. Last year, for example, we saved over $80 million of food and value for here just in Ontario. So, current prices in response to foreign material contamination incidents, that's an issue. This is going to be where we're going to head with the agenda. And then, of course, advancements in X-ray, and then inspection and production recovery. So, basically, with this in mind, let's talk about current practices, which everybody's obviously familiar with. We're all operating under food safety programs or inside your production facilities. Just in Ontario, which I found to be pretty interesting, we have the third largest food processing economy in North America at $35 billion. So it's a pretty good area to focus for a company like ours trying to generate awareness. So basically, our food safety standards are leading to, basically, and it's great that we're working hard at continuously improving those food safety standards, and I think that's a mission that's noble, and we definitely need to go in that direction. But we have to understand that inside of that, there's a major problem that's occurring inside of food waste. So what do, right? We always have to look for innovation. So, basically, to put a number to it, in the analysis work that we've done in market research, just in Canada, we're looking at about $1 billion worth of food due to foreign material contamination going into landfill. So significant, right? So the impacts, obviously, when we're throwing food out inside of production facilities, it's going to impact the supply chain, obviously profitability for the organization, major impacts to the environment, and obviously food security prices, which is significant. So break down in the impacts here. So landfill waste management, which is a significant issue. We all live in this society. These are challenges we all have to face, and basically our waste management is just surging, and anything we do to limit that is a major benefit. Costs I mentioned earlier, basically the disposal charges that you're paying for destruction of the finished goods. That's a significant dollar value, not to mention, obviously, the actual cost of replacing that production for your operation. So basically it affects the competitiveness, and then ultimately something people don't really recognize, there's an 80 times effect in the methane production of throwing finished goods, food into landfills. So that's an emission issue, and obviously it all strikes against sustainability, and directly affects food prices, and something we can definitely do something about. So what do? This innovation, what is it? So, we've, as a society, always had problems and challenges, and at the forefront of that is really innovation, is what typically we've turned to solve these problems. So looking at where we stand here, do a little history on this inspection technology, foreign material and finished goods, leading to problems and costs for your organization, certainly challenging your food safety programs. Give you a little bit of history here. Metal detection. Metal detection has been around actually since the First World War, but in food and commercial application and inline inspection since the 1980s, basically. That's when we started to see metal detectors emerge into inline inspection devices. Again, looking for ferrous content, magnetic, and high conductivity foreign material. So X-rays, Didn't follow too late after that, but basically first generation X-ray, which is essentially just dense, looking for dense contaminant, started to emerge in the 90s, and that was mostly in applications where, the packaging, you're dealing with cans or metallized foils, or basically there's an inability or a challenge that metal detectors couldn't be used. So that's really where it first got adopted. Second generation X-rays, which basically is dual energy solutions, and that's going to basically started giving us better capability, emerged out of the securities inspection, airports basically looking for plastic explosives. So that technology was adopted from there, and that essentially gave you better material discrimination, looking for inorganic to organic. So in the end, it just gave you a better form material inspection net to use. So there's a lot of those solutions out there as well. Third generation X-ray, photon counting is what I'm here to talk to you about today. And that's really new. And you can thank the poultry industry for it, basically. They really drove it, but ultimately it came from CT scanners and Siemens and developing new detection systems, detectors, that completely revolutionized our capability. So today, inside of food processing plants, like 90% of our operations have metal detectors. So we're kind of living in the 80s still. So it's a significant thing. That said, metal detectors are still playing a really valuable role, in food safety. Alongside of Generation 1 and Generation 2 X-ray technologies, it's still very, very essential, but it doesn't do anything towards this issue of finished goods. I'm sure, I'm not going to take a survey, but basically, I'm sure everybody has had a metal hit where your metal detectors didn't pick anything up, yet through a line inspection, you've seen there's metal shavings, and off everything goes on hold. So metal detectors can only do, a certain level of job, and Gen 1 X-rays just not slightly better, much better, but photon counting technology just is a complete safeguard towards most of the foreign material issues they experience in your facility. So what's photon counting? So this is part of when I'm building my presentation, struggled with trying to explain what it takes a couple weeks of academic experience to truly understand what it is. It really is in the detector, okay? So essentially, the detector styles that were in Generation 1 and Generation 2 X-rays, so launched in the 90s and the early 2000s, use basically simulators. And that simulator process, and I'm showing you a slide here, so the new photon technology uses a completely different, like just tear that detector out and throw in the new technology, crystal semiconductors. So the difference being in just looking at how X-ray is produced. So when you're generating X-ray energy from an X-ray tube, passing it through the product, going through the belt, and then your detector sits below, that X-ray is basically photons. And those photons in the older style units, and you can see here basically, you're passing through a ceramic simulator first. So this is X-ray energy passing through the product. So meat, poultry, ready-to-eat meals, whatever it is. And it's getting it's basically getting slowed down by the actual contact with the product and absorbed by the product. So in the old style technology, basically, once it got to the detector, you got to this ceramic simulator, and then at that point, there's a conversion process that happens. It creates basically energy. If a diode will light up and create an electrical impulse that's converted. So there's all these steps. And it's really inefficient, basically. It's like, the best way to explain to you would be for the first digital camera you ever had compared to your iPhone today, right? So the resolution is nowhere near possible, comparable, sorry. And the new technology, photon counting, essentially is just remarkable. It just eliminates all those steps in the process. So the photons are actually absorbed directly into the semiconductor, and they're measured, and they're counted. And correlation with all the algorithms and the outputs of this process inside, because there's two things here. We're generating images with this, right? Then you have the algorithms to actually analyze those images. But you're essentially getting a 400% better resolution than the old style units. What that means is basically you're going to distinguish between organics and inorganic matter, which foreign material, plastics, rubbers, and a whole host of other things, things that we don't want in our food, suspect contaminants, they tend to be, inorganic. So food being organic. So we're able to scrub out the organics out of the image, the food, and what's left is basically things we don't want. So the bottom line is a dramatic enhancement in foreign material detection, which is incredible. And even things on stainless steel. So the example I gave you earlier about stainless steel shavings on a line where your metal detector didn't see it, maybe you have an X-ray, first generation X-ray, didn't see it either. We're getting stainless steel down to like 0.2 millimeters. It's remarkable. So for smaller foreign material detection, and better than it was ever thought possible. So just to finish up, some history on who we are. We've been in the business a bit, coming up 20 years. Basically, we're a division of Plant Automation, this company that I own, with my partner Matt Bedard. And we've opened up 2 years ago, the first 2.5 years ago now, the first food recovery center in Canada, which is X-ray reclaim. So it's basically a turnkey team, processes, facility to remain responsive to any of the emergency hits, on-hold foreign material contamination issues that our clients have. And we've built a pretty big clientele at this point. We're actually trying to work with the provincial government as well to bring attention to this because we see a lot of, obviously the government's behind recycling centers. Well, this is a huge problem. And, we believe more than just a business mission, this is it's a moral mission for us. So basically to wrap up our mission statement, using the best possible inspection technology to support food processors in hitting their sustainability goals. It's not just about saving your company money. It's about food prices, environmental issues. It impacts a number of areas. So this is our mission, and I thank you for your time.
All right, you don't get off that easy. You have any questions for JP? Kicked that light like 6 times today. We've got a mic coming. Here, come take a seat.
Just nothing technical.
Something deeply technical. Ron.
JP, cost between a Generation 2 and a Generation 3. Cost difference.
$60,000, basically. So more to the point, the cost between a standard first generation detector X-ray and the new photon counting, about $80,000 to $90,000.
Any follow-up, Ron?
Hello, hi. This is Debraj here from Jira Foods and Beverage. I have a question here regarding your X-ray thing. So what about the inline? So you have the finished product going through the belt. What about the inline X-ray system?
So is your question about implementing X-ray photon counting technology inline?
Yes.
Yeah, so it's commercially available. It's great pivot off the first question. That's the challenge. It's capital intensive, and I think everybody here is exposed to the process of food safety and budgets. And implementing devices or anything really, and when it comes to capital expenditures, it's really at the end of the day, it's your food processors, your clients are the ones you're going to be operating and responding to in terms of what their requirements are. As I mentioned, Costco and Trader Joe's are the first ones to say X-ray, but they haven't set any standards about what type of foreign material and what the risks are, where you're supposed to go to from your basic foreign material detection levels now down to what? Just implement X-ray. So we're trying to work with Costco also to if they're going to go in this direction, that they go in a way that's educated to help them make best decisions. But basically, sorry I didn't directly answer your question, but basically, yes, there's currently in North America approximately 85 PXT solutions. And these PXT solutions, you'd be surprised at the companies that are implementing them. It's not just, it's the hardest applications. It's some of these, some of these just basically leaders, I would say, inside of food safety. If you're going to do it, implement the best technology is really where I see their mindsets. But yeah, there's about 85 units already in place. But people, we get a lot of response from Costco and clients, food processors coming to us, asking about help in the inspection studies, which we do for them, of course. But their first position is we just need to implement an X-ray. And then after coming to our facility, and we have an education center, we teach where the levels of technology are. I would say there's probably about more than 50% higher conversion rate. People that are coming in to buy on price and really, but then leaving with our mandates food safety and doing the best possible job possible and making the argument with ownership to get PXT technology.
I have a question for you, JP. So something that is a hallmark of the QA/QC universe is creating SOPs. And often it's very difficult to derogate from whatever is down on paper, which can be a problem in a crisis. And so in order to work with X-ray reclaim or a similar entity where your goal is food recovery, how do you engage audience members to make that a possibility in a crisis, right? Like when I'm working through a crisis, like one of the battles that we have is like, here's what your SOP says. Your SOP doesn't say anything about, wheeling your product to a warehouse to have it checked for foreign bodies.
Sure.
What do you do? I mean,
well, it's convention, and basically inside everybody has inside your programs you have deviations and you have plans for responding to different situations. Certainly, foreign material. What we try to mandate and communicate in awareness is basically, it's almost the first thing that I say to any one of you when I connect out there is like, just write us into your program. At least you'll think about calling. So it's essentially a response. It's an established under duress black and white roadmap to working with us. We have immediate contact. Our processes are in place for 24-hour response in terms of inspection validation after we receive your materials. It's a well-heeled, well-established process, and I think if anybody here, we have some clients here who have worked with us, you probably could attest to the fact that it's pretty efficient, and it really is quite professional, and I'm very proud of our team.
That's great. Any questions from the audience?
Hi, I'm Natasha from Metro Supply Chain Group. I just wanted to ask if this new generation of X-ray has impact on food quality. Like, is there going to be some change in the food structure, like protein change, or something else? Is going to
absolutely not. I mean, first off, X-ray. There's been plenty of studies. Obviously, they've been around for a long time, and there's always concerns when new technologies come to the marketplace. So those studies are in place. Essentially, what we're talking about, the change here, is no change in the actual X-ray energy. It's actually after it hits the food and goes through and hits the detector, it's a new detector. So essentially, you're dealing with the same level of energy going at the food.
And I have one more question. What about the calibration of these units?
Pardon me?
Calibration.
Calibration, same as standard X-rays, essentially validation, calibration, same process, kind of in line with what you would expect when you're doing with the metal detector. I think that new technologies. I mean, that's one of the reasons we actually in founding the company that I thought it was a huge necessity. And when X-rays started coming to the Canadian marketplace, when I was back in the day and involved in it, my first thing was like, we have to set up education because these were black boxes for people. So the questions like calibration, questions like cost of ownership, changes to food composition structure, safety issues with them, they're valid. They're all very valid questions and deserve answers. And I think a responsible company, which I'd like to think we are, takes education seriously, and you're all invited to book a time and go through that process with us and inspect our facility. Do a lot of it.
Thank you.
More questions?
Hi, this is Navneet from Trophy Foods. You touched base on the size as well in one of the things when we were talking about the parameters for the X-ray capabilities. So when you're talking about sizes, is it the commodity sizes that could be different, or is the foreign material different size? For example, if we do trail mixes, right, you would have different sizes of mixes going together, and at the same time you could have a challenge of different sizes of foreign materials, right? So have we kind of challenged the X-ray to help us in that scenario as well, and how successful we have been?
So I'm not quite clear to your question. Is about
It's
the
about, size of the product, commodities, right?
An
For
effect
example,
on the size of the foreign material?
Exactly, and
Type of foreign
also,
material?
because that's a complex situation itself, right? When you
Yep.
have one particular product with same size or same shape, it's easier to validate certain equipment. But when you have that complexity within that package itself, and then also you have different foreign materials that could be, right, plastic or,
Sure.
or wood or anything. So how have you come across that scenarios, and how
Yeah, so
successful?
basically, in the end, when a client's approaching us, we're starting with essentially a baseline of foreign material that they're already doing, and if they're coming from metal detection, it's one thing. We know what those foreign materials are. Basically, it's ferrous, non-ferrous, and stainless steel. Moving to X-ray, what we try to encourage is bring us your actual foreign bodies that you have found through the years and you've collected, which I encourage you to retain those. Because even though we know it's nylon or it's some composition of plastic or rubber gasket, there are so many manufacturers of all those materials, of all those possible contaminants that sit inside your process. Once you understand the actual technology itself and how it works, you'll come to respect the need for the inspection validation testing that we do. So we don't just say, yes, we're gonna be able to hit that size, that material on that product. It's a lengthy process, but it involves a collaborative effort. But ultimately, once that's established, you can write it into your CCP.
That's interesting. Actually, having that library, that would help, right? Because that's one of the things that we are also exploring as a demand for Costco, right? It's like you're going through different technologies and seeing what's the best fit. And I guess to your point, it's best to have your own library to start off, because there's so many different types of plastics. Even
Exactly.
For example, the almond, it has, sometimes you could have it within shell, but that could be like it interfaces as a wood as well, so it would not sometimes detect or not detect. Like X-ray has its own, its limitations as well.
So thank you for your question. Are we out of time? Because I have one last comment.
Please. This is great.
Okay. So we're based here. Fortunately, I mean, I think it's a great community and great proximity contact with so many people. But basically, we operate all through North America. So we do this full inspection and rework recovery process turnkey at our facility, but we actually do it mobile. And we're in Houston and Florida right now, and California. So we have mobile teams of X-rays, and it's growing very quickly because of the PXC technology and also the processes. But the one thing I wanted to emphasize and maybe leave you with is that as we begin to generate more and more awareness, I'm climbing higher up inside of organizations, inside of vice presidents and presidents and owners of company, and to communicate this message, because I think it's something that you guys would grab onto, is start looking at this technology as not just food safety. It certainly is that, a food safety technology, but something that's going to truly impact sustainability when it's studied. And I have been brought into, and we have master service agreements and contracts with like billion-dollar companies now to convert all their inspection technology that was in their line just to do food safety inspection, but now also to mitigate loss. Because they've done the analysis work's been done, and 4 or 5 hits inside of a facility come to $1 million pretty fast. So it's financially driven, but it's also sustainability targets. So food safety professionals such as yourself can start to bring that message, a broader mandate, if you will, other than just basically food safety technology.
Awesome. Thank you so much for your questions. It was great. JP, thank you
Thank you.
for sharing this. Take him up on the opportunity to go visit the plant. It's remarkable.